In this video, we are going to talk about a few rules in geometry, and then we're going to use those rules to solve some word problems. So just as a quick reminder, in a perimeter, we're going around the outside and adding up all of the edges around the outside of a shape. In the area, we have different formulas based on the different shape. So a triangle, the area for a triangle is 1/2 of the base times the height. And you do need to look out for where the height is in a triangle. It should always be perpendicular to the base. In a quadrilateral, which is a, rectangle, square, parallelogram, base times height. And in a circle, which we won't have too many of in this particular class, but in a circle, it's going to be pi times the radius squared. In these triangles, let's look quick for where the height is. Remember, the height has to be making a perpendicular, like it's a right angle to the base. So here's my base, here's my height. If I was doing the perimeter, I'm going to do A plus B plus C around the outside. I completely ignore H. But when I'm doing the area, I'm going to do 1/2 of the base times the height. This one is a little bit simpler. The height is right here. These are labeled for trig. Don't worry about that. The height is right here and the base is right here. We could have, if this triangle was like rotated, have the other side be the base and the other side be the height, but like it doesn't really matter as long as they are at perpendicular angles from each other. Again, if we're doing the perimeter, we add up around the outside, 1 plus 2 plus 3. All right. In case we've forgotten, the 3 angles in a triangle will always add up to 180 degrees. When you see the term complementary angle or the complement to an angle, those 2 angles always add up to 90 degrees. And supplementary angles, or the supplement to an angle, those 2 are always going to add up to 180 degrees. Supplementary angles make a straight line every time. So it's like this and this. Those 2 angles are supplementary because they make a straight line. Imagining I drew this nicer. Those 2 angles are complementary because they make a right angle 90 degrees together. In a right triangle, and a right triangle is one that has a right angle in it, the Pythagorean theorem tells us that the squares of the 2 sides added together is equal to the hypotenuse squared. So if we square each side and add them up, it's going to be equal to the hypotenuse squared. The hypotenuse, C, is always the longest side. It's always across from the right angle. That's the most common mistake with the Pythagorean theorem, is looking out for which one C is. We're going to do a little bit of stuff with this. We'll come back to more with the Pythagorean theorem in just a minute. So congruent angles, congruent means they're exactly equal to each other. If you have angles that are across from each other on 2 straight lines, these are always congruent to each other. They're called vertical angles. They're always congruent to each other. So we'll notice here that 1 and 3 are congruent to each other. They're equal. They have the same measure. And 2 and 4 are equal to each other. Now, reminder from your high school geometry class that we also have all of these fun names for other angles that are equal to each other. The names are not super important to me, but what is important is that you know what is congruent to each other. So if these lines are parallel, and they are in this problem, but you really have to double check in your problems to make sure. If these 2 lines are parallel, then 1 and 7 are equal to each other, and 3 and 5 are equal to each other. And since 1 and 3 are equal, well, 7 and 5 are also equal. All 4 of those angles I just circled in red are congruent to each other. Similarly, 2 and 4 and 6 and 8 are all congruent to each other. They're exactly the same. So like if this one was 100, then this one was 80, because they make a straight line. 100 plus 80 is 180. And this is 100, and this is 80, and this is 100, and this is 80, and this is 80, and this is 100. If you know one angle in a setup like this with two parallel lines with a transversal going through it, you know all 8 of these angles. So let's use our properties of triangles to find a missing angle. Remembering that the 3 angles add up to 180, I know 70 plus 50 plus this has to be 180. So I just have to figure out what is left to make 180. And since 70 and 50 together makes 120, if I subtract that, I can see there's 60 left, and that's what A has to be, 60 degrees. On right triangles, don't forget this little square means it's a right angle, which means it's 90 degrees. So here I have a 90-degree angle and a 25-degree angle and my missing angle. And so the missing angle has to be whatever I have left to get to 180. And in this case, that is going to be 65 degrees. 115 plus 65 is going to make 180, or I subtracted on both sides. Angles in a triangle. Now, exactly the same idea, but much worse. Word problems. Okay. So I have a triangle. I have 3 angles, 1 plus 2 plus 3, and they make 180 degrees. Okay. I just know that every time. Now let's read the word problem. The second angle of a triangle, we'll call this the second one, is 30 degrees larger than the smallest angle. We'll say that the smallest is the first. So it's 30 more than the smallest. Let's just say that the smallest is x. Then this one is going to be x plus 30. Now I'm on to my next sentence. The third angle, we'll say that's this one, is 4 times as big as the smallest angle. So my smallest angle is x, which means I'm going to go 4 times x to find my third angle. Look at this. I wrote myself a lovely equation. Let's simplify it. I have 1x and another x and 4 more x's. I have 6 x's. Still have that plus 30 to make 180. I'm going to solve for x to get it all by itself on one side. And once I do that, I'll be able to find what x is. X in this one was my smallest angle. So my smallest one was 25. 25 plus 30, this one was 55. And 25 times 4, this was 100 degrees. Double checking that these all add up to 180. Yes, fantastic. We solved it. Similar, different. Let's keep going. First angle, second angle, third angle equals 180. The second angle of a triangle is 90 more than the first angle. So if this one was x, this one's x plus 90. The third angle is 3 times the first. The first was x, so 3x. We're going to add these all up, and we're just going to solve just like we did in the last problem. We have just different numbers, same thing going on. Oh, sorry, subtract 90 on both sides. And when we divide that, we get x is 18. So the first angle is 18. The next was 18 plus 90, 108. And the third one was 18 times 3, which is, 54. I'm hoping that's correct. Do those still make 180? Looks like it. All right, let's do the perimeter of this triangle. We're going to add up around the outside. 9 plus 11 plus 14 around the outside every time. We get 9 plus 11 is 20, plus 14 is 34 meters. When we're finding the area of this triangle, 1/2 base times height. And this is going to be in meters squared because we're in 2-dimensional space now. So 1/2 of my base was 14 and my height was 7. 1/2 of 14 times 7. Half of 14 is 7. 7 times 7 is 49 square meters for my area of this triangle. All right, now we've got a missing side, and we know that the perimeter is 36. That means that around the outside is 36. So I can say that 36 equals 9 plus 12 plus something. We We could make it x. We could make it whatever we want. So solving for x, we're going to try to get x all by itself on one side. My missing side must be 15 centimeters. All right, still perimeter, but word problems. All right, we're on a rectangle. If you're in a word problem, I just highly recommend you draw yourself a picture every time. So the length is 5 centimeters greater than the width. I never really know which side is supposed to be length and which side is supposed to be width. Let's say this one's width. And the length is 5 more than the width. So it's the width plus 5, yeah? My perimeter is 150, and I have to find both the width and the length. Now remember that my perimeter is, sorry you have to hear me say it so many times, around the outside. So we're going to add up all 4 of the sides of this triangle. Rectangle, it's a rectangle. So it was 1, 2, 3, 4 sides. Let's add up all my W's. And then I have a 5 and a 5 is 10. That's just combining like terms there. We're going to get 10 all by itself. W all by itself on one side. We're going to divide by 4. What is that? 35. So my width is 35. Since the length was 5 more than that, my length had better be 40. Ooh, not W, length, or W plus 5. All right, the perimeter of a triangle is 69 centimeters. And we've got side A, side B, and side C. Side A is 5 centimeters shorter than B, okay? It's the same as B, take away 5. Side C is twice as long as side A. Oh boy, it's the same as 2 times A. Find the length of each side. So A plus B plus C is 69. Fantastic. We know that at least. We know that A is actually the same as B minus 5. So let's put that in instead for A. And we know that C is the same as 2 times A. But listen, I don't want to put A back in. I just took it out. So instead of A, let's put what we know A is equal to. B minus 5. So I have A plus B plus 2 times A is C, sorry. All right, let's do some solving. First, I'm going to distribute, and I'm going to combine some like terms. I've got a B and another B and 2 more B's. And a negative 5 and a negative 10 makes a negative 15. I'm going to add 15 to both sides. What have we got here? 4B equals what? 84. Divide by 4. And I know that side B is equal to the number that is. What is it? It's 80 is 20. 21. It's 21, right? Yeah, great. So the length of each side, though, it said, huh? So B is 21. A is 5 less than that, so 21 minus 5. And C is twice as much as A, so 16 times 2. And hopefully when I add these up, it's still going to give me 69. The Pythagorean theorem we touched on really quickly earlier in the quick review. When we've got a right triangle, we've got 2 sides that we label A and B. Doesn't really matter which one's A, which one's B. And then we have a hypotenuse C that's always across from the right angle, and it's always the longest side in my triangle. We named it after Pythagoras. Why? Anyway, doesn't matter. Let's keep going. The Babylonians were using it long before him. But anyway, we can use this to find a missing side of a right triangle because we know of this special relationship between all 3 sides. So let's look at a problem. We have here A is 15, B we don't know, and C is 17. Side note, could this have been A and this have been B? Absolutely. We just didn't have that. We didn't decide to do that, but it's all just a choice. Anyway, let's solve. So a squared plus b squared equals c squared. Honestly, write it every time. But anyway, 15 squared plus b squared equals 17 squared. And now we're going to see what those numbers really are, right? 15 squared is 225. 17 squared I have to do because I don't know it off the top, 289. We still have b squared. We want to try to get b all by itself, so we're going to subtract that 225 on both sides, and that leaves me 64 here. Now, that does not mean that side B was 64 centimeters, right? Because this is B squared. We're going to need to use the inverse operation from squared, which is square root. So we're going to square root on both sides of this equation. That leaves me just B. And if you know the square root of 64, fantastic. If you don't, you can use your calculator. This one is a perfect square, so it has a nice number. It's 8. But if it was the square root of 65, then it's going to be an irrational number with a very long infinite decimal expansion. And so you will usually round those. Let's try another. All right, we've got 3, we've got 8, we've got x. A squared plus b squared equals c squared. This time I'm missing my hypotenuse. So I'm going to have 3 squared plus 8 squared equals c squared. What is this? 9 plus 64 makes 73. To get c all by itself, I better do square roots on both sides. And the square root of 73 is not a nice number. That is an irrational number for sure. Now, depending on your teacher, you can just leave it square root 73 for a lot of math professors. If they would like a rounded decimal expansion, we're going to put it in our calculator and see what we get. Square root of 73 is 8.5440037, blah, 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 blah. It literally goes on forever. So let's round it to 8.5. Good. All right, notice we've got our hypotenuse. This could be A or B, it doesn't really matter. Usually we do the one that's across, but boy, that did not work in this one. We'll say this is A and this is B. Why not? A squared plus B squared equals C squared. So we don't know A. And B is 6 and C is 10. Let's do it. Subtract 36 from both sides, and we've got a squared equals 64. Hey, this is a great one. I already know the answer because we did a square root of 64 recently. It's 8. Amazing. All right, you're going to see word problems about Pythagorean theorems, and quite often there's like a flag or a ladder or something leaning. The leaning thing is your hypotenuse. You can always draw yourself a picture. And then your other things are going to be A and B. Doesn't matter, right? Which one is which, but pick one you like. So A, I don't know. B is 12. C, is 13. I shouldn't write C because I know that it's 13. All right. So get an A all by itself on one side. We've got 25 square root on both sides. That leaves me just A, and the square root of 25 is 5. How nice. Sidebar, there's not that many Pythagorean triples, which means like ones where we have nice whole numbers on all 3 sides. So a lot of times you're going to be rounding or leaving a radical in your answer like this. Totally fine. Ooh, look at this, trying to trick us by having it turned. Where's the right angle? There's the hypotenuse, all right? A squared plus B squared equals C squared. I don't know the hypotenuse. I know everything else. Oh boy, do I know 14 squared off the top? I don't. Let's do it. It's 190. Oh, I did know that. 196. I definitely don't know 48 squared off the top of my head, but my handy calculator is here for me. I'm going to add these together. Ooh, I got 2,500. To get C all by itself, since currently it's squared, I'm going to need to square root it. And I think we're going to get 50, right? Absolutely. One other thing. The hypotenuse is always the longest side. So if you got a number here that was smaller than 48, something went wrong.